Hey robot makers, hope you're having a good day so far. So, do you want to learn about network attached storage and why I'm switching from a DIY true NAS to a Synology drive? Then this is the show for you. Let's dive straight in. My name's Kevin. Come with the ways we build robots and projects, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our slides for today. So yes, I've finally bitten the bullet and ordered a Synology NAS drive, and I want to tell you about why I've done this, the kind of rationale behind this, because it's quite an expensive move to make. So I'm a bit of a data hoarder. I like to store all my stuff, and how I've done that to date is I built my own NAS solution. I actually started a long time ago with a Solaris server. This is one I built myself when Solaris used to be a free operating system, and it was run by Sun Microsystems, and they had this great Solaris operating system. It's kind of like Linux FreeBSD, but it's its own thing. It's Unix variant, and I had a bunch of hard drives in there, and they were all added together in a ZFS array. We'll get into what all that means shortly. We can see on the screen there the top right picture. That's the current. I think that's a thermal take case that I bought quite a long time ago. It's quite an old server, that one. I think it's about 12 years old, and that has 5 1 terabyte SSDs, and they are all kind of added together to provide 5 terabytes. Well, in fact, it's 4 terabytes of storage. Really fast storage, but 4 terabytes nonetheless. I also have a whole bunch of external drives, such as these here. Lots of different sizes, different types of drives. Some just connected via USB, some connect via network, some use different types of USB connector. That's a USB-C one there. So a whole bunch of different external disks. There's a lot more under the desk that you can't see. I think there's at least 4 under there. So there's one of the orange rugged ones you can just see on the picture below there. And then there's 3 passport drives. And I think they're all about 6 terabytes each. So all over the place with drives and data. So my projects kind of span different disks depending on what I'm working on. A lot of the content is actually what you're watching now. It's video content, and it takes up quite a bit of space when you're editing these video files down. So I've got partial backups of data. So one of them drives will be the kind of source data, and then another drive will be a backup of that source data. I also have a Time Machine backup, which is for my Apple Mac, which is what I'm using now to broadcast this. So that backs up to a Time Machine drive as well. That's another external drive. I think that's the orange lacy, the rugged one. And I don't actually need to have ultra fast storage. I really just need a very large capacity storage that's got some resilience to it, and we'll talk about what that means in a second. And I also want to be able to back that up as well, and we'll also talk about backup regimes. So that's the kind of problem I'm trying to solve. So we're going to be moving from this kind of collection of disks and a full server to a Synology drive, which has got, the one I've gone for is the DS1522 Plus. The way that these work with Synology, they have like car years. So the 22 actually means this came out in 2022, so it's a little bit old as a model, but I don't really care about the processor or that kind of stuff. I'm really just going after the operating system that it runs on it, which is really nice, and the way that it manages the drives. We'll get into why that's a little bit different a bit later on. So I've originally, to set up this, I bought 3 of these 16 terabyte HD. So these are spinning disks. Like I said, it doesn't need to be ultra fast, just very large. And we're going to add those capacity together, and I'll tell you about how we're going to do that throughout these slides. And that will provide me with about 32 terabytes of storage. We kind of lose 1 drive's worth of storage, and I'll explain precisely why that is in a second or two. I will also have, for now, an external drive to back up some of that storage. Now, like I said, currently I've got about I think 6 terabytes is the largest external drive that I've got, so there's going to come a point where I can't back up everything, and I'll have to selectively choose what I back up. But the Synology software will help me manage that. Now, just out of interest, the drives have arrived, but the actual enclosure is still on its way, so it may actually arrive during the show today. If it does, we'll do an unboxing of that. Otherwise, we'll have to do that as a midweek cheeky video, I think. So that's what we're going from. That's the goal and the 2. moving to. So 321, have you heard about this when talking about data backups? If you don't currently back up your data, then you stand the risk of losing that data. Now, storing that data into the cloud means that it's got some resilience to it, but that isn't actually a backup. A backup is an extra copy of your data that you store somewhere else. So 321 is how you remember backups. So the idea is that you have 3 copies of your data. You have that on 2 different storage types, and then you have 1 copy of that which is off-site. So ideally, if you have like a NAS storage and that's going to be part of your backup solution, you would have one of those off-site as well, maybe at a parent or friend's house, or maybe you ship that off and send it to a storage location somewhere, but it's not physically in the same location, because if there's anything to happen to that location, say there's a fire or a flood, you would again lose everything. So 321 is like a really important concept when looking at backups, and we'll look at why the backups is different than resiliency, and it's easy to get the two kind of confused in this modern day where we have a computer and we have cloud storage and we move things between the two. That would really only just be 2 copies of the data, and typically you only have like a small portion of that entire cloud storage that you might have on your local machine. So again, you've only really got 1 copy of it in the cloud and you've got a partial replica of it on your machine. So my current situation is I don't have 3 copies, I've got 2 copies, and they are kind of all over the place. They're on different drives, different external drives. Some of them are connected up, some of them are not connected up. I would have to go hunting for things if I wanted to find a particular piece of footage. And since buying like a drone and GoPros and all kinds of like iPhone footage that I will take, I built up quite a lot of footage, and that's the majority of the bulk of the large data that I'm looking to store. Actual code for writing programs for robots, that's really small actually, so that doesn't take up anywhere near as much space as the raw footage. So different types of storage. I do actually have 2 different types. So I've got external disks currently, and I also have the NAS. So I actually have a network area storage box, or network attached storage, which is just to the left, just beneath here, and that's the thermal take box that I've got. That's we're going to actually have a look at that on the demo. I'll show you how that kind of works. So that's running some software that's called TrueNAS, which is an open source free piece of software that runs FreeBSD underneath. So it's kind of like Linux. 1 offsite copy. I don't currently have any offsite, so all my storage and all my files really are just here. I do have some cloud storage, but I don't use that to store all the video files. They're all basically just on these drives under the desk. So, we talked before about data resilience. So data resilience refers to the system's ability to withstand failures and still provide access to the data without any kind of loss. So if you think about something like Google Drive, Microsoft OneDrive, Apple iCloud, they are resilient in that you can put a file on there, and that file is pretty much going to stay on there until Microsoft, Apple or Google have some kind of critical error where they lose their data center, and that's very unlikely to happen. In fact, they will actually have copies of your data all over the world potentially, and when you access it, you'll probably access a local version of that file, but they'll have lots of different copies of that data, and they will also back that up for you, and that happens all transparently so that your files are always there when you need them. So that kind of having copies of things and storing it in different geographic locations, that's part of the data resilience. Now, redundancy means that we have additional copies of data. Now, one of the terms that we'll talk about today, and we'll get into that in depth, is something called RAID, or redundant array of inexpensive or independent disks. RAID means that you can have several disks, you can add all the storage capacity of those together, more or less, and then you've got the full capabilities of all those drives added together, and that provides some additional benefits. It's much faster than writing to a single drive, and if you set up your RAID array correctly, you can actually lose an entire drive and still have access to all your data even though one of those drives has died or been moved. We'll talk about precisely how that works. It's quite a magical piece of maths that makes that happen. Hot swappable drives. So this is the idea that if one of the drives did fail, you could swap that out with a brand new disk, and the RAID array will be able to rebuild that missing data from the data that it has on the other disks. Error correction mechanisms such as ECC, error correcting RAM, that allows you to have in sort of very expensive NAS solutions every step of the way where that data comes in from the network port all the way to writing it on the disk has error correction to make sure that that data doesn't get corrupted along the way. We're going to look at snapshots as well. Snapshots is essentially a point-in-time copy of your data, and there's some clever ways that we can do that using modern file systems. We'll have a look at that. That's called copy on write, and snapshots work very well with copy on write. We'll have a look at what that means very shortly. And uninterruptible power supply. So I've got a great big power brick at my feet over here, and should the power knock out to this room, the actual disks and my laptop, and I think my routers as well for the internet, they're all on this battery backup, and they can carry on working for a period of time and kind of gracefully shut things down without having to just kill the files mid-write or something. So UPSs, or uninterruptible power supplies, are essentially a great big battery. We actually have 3 of them in the house. I'm looking to get an extra one for the mini rack that I have behind me that will be running the Raspberry Pis, which runs my Kes Robots Empire. So, RAID, we talked about a redundant array of inexpensive or independent disks. So I bought 3 disks, and these are 16 terabytes each. So you would think we'll be able to get the full capacity of all those drives if you add them together. But with RAID, we can actually have different levels of redundancy. So RAID 0 means we have no protection. We're just going to add together those drive capacities and write files on each of them as if they are one big super drive. So it means it's really efficient from a capacity point of view. It's very, very fast because you can write to all 3 drives at the same time. However, it's not got any kind of redundancy or resiliency built in there. So if one of those drives dies, you lose the entire volume. You lose everything that was on all of those drives. You would have to send this off to a recovery expert to get the files back off the ones which were part of that set, not the one that's died. RAID level 1 means that we have mirroring. So essentially we have 2 disks and they'll mirror each other. So everything that you write to one drive gets written to the second drive at the same time. And that means any one drive can fail and you've still got a complete copy of all that data on the other drive. Now that's really fast. However, from a storage efficiency point of view, you're giving away half of your capacity to that redundancy. So it's not particularly efficient from that point of view. It's great for if you want to make sure you've got that redundancy and it's there, but it's not the best way of doing that. Now RAID 5 is probably one of the most common ones, and this is where we can balance the speed and the redundancy by having at least 3 drives. So instead of mirroring an entire drive, we can set one drive, and it's not a particular drive, it's just the storage that's used by all 3 drives. A third of it will be used to store something called parity data, and we'll have a look at how that works because, like I said, it's quite magical, quite clever. The more drives that we add to our array, the less that storage efficiency or the greater the efficiency becomes. So if we have 4 drives, we're only giving away a quarter to the parity. If we have 5 drives, it's just 20%, it's just a fifth of the capacity, and so on. So the larger number of drives that you have, the better it can use that storage capacity and less use of the parity. So file servers typically use this, and this is what I'll be using on my new NAS solution. It's what I currently use on my existing one. RAID 6 means that we can have 2 drives fail. So instead of just having the parity written to one drive or one drive's worth of capacity, we actually write it twice. So again, the efficiency isn't great, but you've got extra redundancy. So if you've got some really important commercial file servers and you need to have that extra safety net, then having that RAID 6 will give you that. And then RAID 10 means that you have multiple mirrors in effect of each of them. So it's kind of like a RAID 5 but with mirrors. So you need twice the number of drives that you would for a RAID 5 configuration. So you need at least 4 drives, and they're in even numbers because you're having that kind of mirroring effect. So this is great for things like databases, high performance servers where you need many drives writing at the same time. But it's not particularly efficient from a capacity usage perspective. So it can survive multiple failures on multiple drives. So that's the most amount of RAID that you can possibly have there. So they're the common RAID levels. RAID 5 is probably the most common. Some servers use RAID RAID 1 for their boot volume, so if they're booting up, if one of them fails, it can carry on. Now you can actually implement RAID in hardware, or you can implement it in software. So hardware RAID is typically if you have a server like a rack server, that might have it might have a RAID controller in there, and you put the drives in and it just presents that back to the operating system level as a single drive, and it will handle all the parity and reading and writing to those drives as a single volume. You can also do it in software, which means that the CPU of your machine has to figure all that out for you. It has to be able to take the write requests from the operating system and then figure out how to break that across all the different drives that you have in your RAID array, depending on what RAID configuration that you have there. So software is actually the most common way of doing RAID. It works on all Linux computers. Macs have RAID capabilities as well, and Windows does too. So whatever computer you're using, more than likely it can do RAID. The only thing I think, the only exception to that is probably Chromebooks. They don't tend to implement this. They just have a single drive. So how does RAID work? This is really magical. When I understood how this worked, I was like, that is so clever. So blocks of data. So if you have a file, say it's your like a great big spreadsheet, and that's actually made up of lots of blocks of data. Now, depending on the size of your drive, a data block might be a different size. So it might be anywhere between 4 kilobytes and say 64 kilobytes. The larger the drive, the larger the block sizes tend to be. And that's relative to if you want to be able to index all those blocks so that you can actually access them in a meaningful way. The more blocks you have, the bigger that index has to be, and the more of that capacity that it will take up. So there's typically an algorithm at work. Depending on the size of the drive, it will also define what the block size is. So a block in our sense is going to be a chunk of data. So our spreadsheet, let's say for argument's sake, is made up of 5 chunks of data, just because it fits nicely with what I'm illustrating here. And when we write that block of data, or those 5 blocks of data, onto our RAID array, we call that a stripe, because we stripe it across all the drives. And what we will do is we will work out from that block of data what is the parity information for that block of data. And parity is like a special checksum. I'll actually show you the algorithm that works in a very simplistic way so you can actually understand this, and it's just so clever how it works. So essentially we can take, say, instead of 5, let's just go with 4 blocks with 1 parity, just because we've got these 5 disks there. So the blocks of data can be added together using XOR, which is exclusive OR. We'll have a look at exclusive OR on the next slide. And it can then work out what the parity information will be. And parity can rebuild the data if one of those drives goes down. And it doesn't matter which drive it is, it can actually work it out from the drives, the data that's on the other drives using this XOR function. So as long as we break down the blocks of data and we stripe them across all the drives, and we include that parity information on one of the drives, and it doesn't matter which one, it can actually change each time you write data. That means that any one drive can fail and we can get that data back. Now if 2 drives failed and we only have the RAID set to like a RAID 5, then we will lose all the data on all of the drives because we can't actually get that data back. So we choose what we want to set the RAID level to be. Is it going to be RAID 5, RAID 6, RAID 10, depending on what our needs are. So I'm going to be choosing RAID 5 on mine because I want to be able to have at least 1 drive fail and be able to keep working, because the chances of all 3 drives failing at exactly the same moment is quite small, but over time that will get higher and higher. All drives have a mean time between failure, so that means it's like a length of time, a lifetime of your drive, and it might be like between 4 and 10 years, for example, for any given drive, and the manufacturer will tell you that when you purchase your drive, so you can actually see how long is this drive likely to last for. Now in my experience, spinning hard drives can last anywhere between like 6 and 20 years depending on how often you use that and the kind of conditions it's in. So if it's living in a nice cool environment, there's plenty of like heat ventilation, so it's not getting cooked in a loft somewhere, then it will probably last quite a long time. drives like to be spinning consistently with no kind of starts and stops. So if you frequently start up and shut down your NAS or your server or your machine, then you'll find that that drive will actually wear more, because the starting up and slowing down wears more than just continually having that running. So parity, fantastic. Let's have a look and see how that actually works. Yeah, I think it's just quite magical, this. So an exclusive OR is a function. It will take two inputs. So we can see there on the right hand side, if we have an X and a Y, whenever that is a 1, well, when any one of the inputs is a 1, then the result will be a 1. So if we have 0, 0 as the input, this is like a math function, if you like, exclusive OR, then we get a 0. If we have 0, 1, we'll get a 1, because one of the input values is 1. We can have x1 and y0, that will also result in a 1. If x and y are both 1, then exclusive OR says they're not, one of them isn't 0, therefore that's going to be resulting in a 0 output. Now we can use this truth table to add together the data from each of our blocks. And we can do this in quite large chunks. It doesn't have to be 4-bit binary things like this. I just wanted to kind of illustrate this. So if we got 4 data blocks, A, B, C, and D, and we've got the data in each of those. So data block A, for example, is 1101. You can see that we've kind of striped that across our disk there. To work out what the parity is, we simply do this XOR function to all those blocks, and whatever we end up with, that's what we write as our parity data. Now what's really clever about this is if you were to delete any of those other disks, you can rebuild the data that was on that disk simply by adding that, just doing the XOR function again, and by how the math function works, you will get that original data back. So it's really clever. It just requires n-1. So how many disks you've got, -1 is the capacity that it will take up to work out what that parity information is. So if we were to lose that disk B there, we've now just got 3 disks and our parity information on the 4th disk. We can use that parity XOR function there to work out what the missing data is. So it can resilver a new disk. If we pop in a new disk, a new hot swappable disk, it can then rebuild that just from the information that's on the other ones. So really, really clever algorithm, very simple in how it works, but really fast. And it means that we can have redundancy and resiliency in our RAID array. So really clever, just using XOR. So checksums. Checksums are an additional piece of information that we can add to our data block. And file systems such as ZFS, BTRFS, they can actually include a checksum on every single block of data that's written to the disk. So a checksum is like a digital fingerprint. It will allow you to take a piece of data, and you can see by just looking at the checksum whether that data is valid or not, whether it's the original data that was written to the disk or not. And in fact, your credit card has a checksum on it. So you're using checksums every day, every time you use your credit card. The very last digit on your credit card is a checksum of all the other digits. So you can see on the right hand side there a bit of a brief explanation of how that works with credit card checksums. And checksums on file systems are kind of similar. They use a different algorithm. Is it called the law algorithm for credit cards? I can't quite remember now, but yes, it's very straightforward to take a bunch of numbers. It essentially adds them together with a bit of extra math in there, and then it stores the result of that as the last digit. And if you look at that last digit, run that same algorithm again, you can see if there's any typos or if that number is actually correct. Checksums on disk work exactly the same way. So if you're writing, you got this picture of your daughter's graduation and you want to make sure you never lose that photograph, if you write that to a file system that has checksums enabled, then you can guarantee that each data block on there is as it was originally written. The file system underneath can check when it's reading those data blocks and say, that's valid, this file is as it was originally written down. Now, if you think back to our RAID striping of all that data, when the RAID software level reads data from the disk, it can actually read the checksum, and if it decides that that checksum isn't actually correct, it can go to the parity block and it can rebuild what that data should be. It can self-heal by building that data block up as if that disk had failed. So data checksums are an extra level of protection for your data. I wrote an article about 20 years ago on data rot, which is how ones can become zeros over time. Zeros can become ones, they can flip. And this can happen on archive media. So it's really important we have things like checksums to be able to rebuild and check and know when to go to the redundant storage and get that data block back, because the chances of both of them failing in exactly the same way is very, very small. So checksums like this digital fingerprint, like I said, ZFS and BTRFS also have checksums and available for every single data block. One of the things I was interested in when I did my computer science degree, I actually did my thesis on file systems, so it's one of the things that I'm quite interested in. When Apple came out with their new advanced file system, APFS, which is the Apple file system that's used on every iPad, iPhone and Mac nowadays, they chose not to have checksum data on the file data, but just have the checksum data on the structure of those files. So the file system, the directory structures, that all has checksums, but the actual data itself, they just rely on ECC, which is that error correction, which is part of the low-level drive system. So I don't know why they decided not to do that, but that was just one of the things that they decided to exclude from APFS. So how do checksums work? There's a generation, so when you're writing your data to the disk, the file system calculates a unique checksum, which is like a really small number, really small piece of data based on each block of data. When we then store the file, the checksum is stored alongside that data block, either in the data block metadata or in a separate location. It could be stored in like the file allocation table, as it used to be called, or it can just be stored within that stripe of data that you're writing. Verification, so when you're reading that data back, the file system can recalculate the checksum based on the data that's read in, and it can then compare that to the checksum that's been written to the disk. When it does that comparison, it can compare that stored checksum with the calculated checksum, and then it can either get a match, in which case the data is highly likely that it's intact, or if there's a mismatch, then the checksums don't match, it indicates that some kind of data corruption has occurred, and it can then look to the parity information, or the if you've got a mirror, it can look to the mirror partition, and it can grab the data from there and do that same checksum again to see, does this look correct? Now, the likelihood of a checksum having a false positive, so it reporting back that the data is fine but the data is actually corrupt, is very, very small, and that's down to the complexity of the algorithm that generates these. So it is possible that the checksum has incorrectly added up the data and it gets a number, and that number just happens to be the same one as a valid set of data, but again, it's very, very unlikely for that to actually happen. So that's how checksums work. Now, we can typically, on a modern file system such as BTRFS, ZFS, even the Apple APFS, you can get the file system to do what we call a scrub. And a scrub simply means it's going to read in each block of data, and it's just going to compare the checksum to what it's read in to do that comparison verification step. If it finds any issues, it can then do that self-healing thing where it can look to a redundant copy of that data if you have one, because you've got a RAID array, and it can then rebuild that data. So you can't rebuild the data just from the checksum. The checksum just tells you if the data is valid or not. So it's just that little extra check, like your credit card final number. So if you like what I do and you want me to make more of these kinds of videos, please give this video a like. Now, on the comments, I want you to answer me a question. I've just put this as a poll for our live stream viewers. So let me know, do you currently use a network attached storage? If you do, tell me what brand that you use and how large that data capacity is on that drive. I'm very interested to know what people have out there and what brand of NAS that you have. And if you've not subscribed to the channel, please subscribe. It means so much to me that people subscribe. I do go live every single Sunday, so we're now in British summertime, so we've kind of got parity with the US daylight savings time, so this is now 7 o'clock British summertime. Okay, so build versus buy. So I have built my own NAS server, like I said, 20 years ago. I started out with 3 or 4 500 gig disks, spinning disks, and I used Solaris and ZFS to build out that storage device, and it worked very, very, very reliably. I think I added in additional disks later on. So one of the cool things with that ZFS was you could swap out each drive one at a time. You would let it resilver, which is the building back up from the parity data as if the drive had failed, and then you could put in a high capacity. And when you put in the final high capacity drive, if all the drives are the same size, then you'll then suddenly have twice the capacity there if you put in, say, 1 TB drives from your 500. I also put in a cache drive. So a cache drive just helps the typically if you've got spinning disks, they are much slower than solid state drives, SSD drives. If you have a cache drive, you can typically use a small amount of that faster solid state drive to store some files temporarily, and it just makes the whole thing much faster. So I included a hot swappable drive and also that cache drive, and the hot swappable drive was just there on standby, not storing any data, and if any of the drives were detected as failed, it could immediately use that hot swappable drive as if we'd put in a new drive for it to use, and it can then indicate that there's a problem with the drive. So I did this with TrueNAS. Later on, I migrated from Solaris when that got bought out by Oracle. I then moved to TrueNAS. I think originally it was FreeBSD, but TrueNAS has got a nicer web interface. We'll have a look at that in a minute. So yes, pros for building your own NAS storage. So you can really customize this to your exact needs. So originally when I built my TrueNAS server, or the latest incarnation of it, I used all solid state drives, so 1 TB solid state drives. I think I've got 5 of them in there, and that meant that the drives are very fast, and I could almost, if I wanted to, edit from that straight on my Mac. However, I didn't have a very fast network connection behind all this, so actually editing from that is slightly jittery, and it's just down to the not having a 10 gig network between the server and my Mac. I also had another issue that we'll come to in the cons in a second. So cost effectiveness, building your own NAS is definitely going to be the cheaper option than buying a pre-built solution. So the operating system FreeNAS is completely free. All you need to do is just provide some hardware. And the hardware doesn't even have to be particularly fancy. You can just bung in a bunch of disks. FreeNAS will help you configure that in a RAID configuration, and you can use that combined capacity of all the drives on your network. Even has all the capabilities of running things like containers, Docker containers and things like that on your NAS as well. So FreeNAS, lots of love for FreeNAS. Performance wise, you can optimize your drives, your DIY NAS solution for performance like I did with the pure SSD configuration. Or if you just want lots of large drives, you can go for that as well. So it's entirely down to your own choosing. And it is also a learning experience. So building your NAS, you'll learn lots of interesting things, I think, if you're into computers that you wouldn't otherwise learn. Now, cons-wise, it is quite complex and time-consuming and requires a certain level of knowledge to be able to configure a network area storage, network attached storage. Support and maintenance, so you're not going to get any customer support or warranties. You're not paying for that essentially, so you're not going to get that. You're just going to have to figure that out yourself using the internet as your friend, perhaps. Reliability, now this is one of the main reasons why I'm switching from a TrueNAS solution to a Synology solution. It's something to do with how I built my solution. So I've got a RAID card in there, which I think, well, it's a SATA controller card that has about 10 SATA interfaces on it. That connects into like a PCI Express on the motherboard of the computer, and I've got a bunch of memory in there. We'll have a look how much that is in a minute. I can't remember off the top of my head how much RAM's in there, maybe 16 or 32 gig of RAM. And what I find is if I write a whole bunch of files across to this TrueNAS box, halfway through the file transfer, it'll just reset the connection, not the actual operating system, just the connection, as if somebody's pulled the plug and then plugged it back in again. And I don't know what's causing that to happen. And I think it's probably the RAID controller card just isn't 100% compatible with FreeNAS. And that's one of the choices, the chances you take when you build your own stuff. You're not necessarily using compatible equipment. So the drives and the drive controller and the motherboard and the operating system all have to work in unison for it to be really reliable. So my solution isn't reliable. It works most of the time, but not all of the time. And for me, that's just not good enough. And it's also full as well. And security concerns. So configuring a secure network attached storage can be really complex and means it's vulnerable to hacking and data loss, which is really not what you want. I work in cybersecurity in my day job, and I was thinking I need to apply some of this in my day-to-day video editing stuff as well, because you know, if I lost all my video files, I'd be really, really unhappy about that. So I need to apply some of that professional stuff to my my hobby as well. So let's have a look at buying a solution. So ease of use. Commercial NAS systems are designed to be user-friendly and easy to use. Synology is no different. So when my Synology drive arrives, I'll probably do a video of how I set that up as well, just to show you how easy that is. You do get a warranty and and support typically when you buy one of these things for a certain amount of time. So any kind of initial problems that you have, you can then troubleshoot them with a supplier and get the answer quickly. Reliability wise, typically you will get a compatibility list of drives that have been tested with a NAS storage enclosure. So I've been through, the compatibility list when I bought these Exos drives. These are Seagate drives, and Seagate 16 terabyte drives were on the list of supported drives by Synology, so I can buy those. I understand Synology are releasing a whole bunch of drives this year, and they might only have they might only be able to use drives that Synology provide their sticker on. So watch this space for that one. Currently, you can use any drive that you wish in there. They prefer you to use ones that are on the compatibility list. And in fact, if you plug a drive in that isn't on the compatibility list, it'll just flag up and just say, are you sure you want to do this? It's not necessarily supported. So reliability wise, you get more reliable solutions when you pay for them, and if you follow the right compatibility lists. So you're less likely to experience any kind of problems on that. And then software features. Many NAS devices come with proprietary software features. So Synology has a really interesting one, which is called Synology Hybrid RAID, or SHR. And that can do a really clever thing where normally in a RAID, all your drives have to be the same size for you to get a volume or a storage pool to work on them. If you have different sizes of drives, essentially it's the lowest common denominator. Whatever the smallest drive is will define the amount that you can use from each of those disks. It's as if each of those disks are the smaller size. So if you've got one 500 gigabyte drive and 3 terabyte drives, you'll only be able to use 500 gig from each drive, and it'll actually waste the rest of the storage on there. With the Synology Hybrid RAID, you can actually use the additional storage that's available on the larger drives, as well as using all the capacity on the smaller drives. And they do that essentially creating like a mini RAID for the larger capacity drives that, if you think about is it being kind of a shape that kind of sticks above the rest of the drives, it can use that extra shape at the top to create a little RAID configuration between those. So any drive can go and fail, and you will still be able to get that data back as long as it's you have that RAID set up correctly. So one of the features, as I said, I'm looking forward to using on the Synology drive is that Synology Hybrid RAID, and there's also a couple of other features on there that I'm quite interested in trying out too. So cons wise, can be a lot more expensive than building your own, like significantly more expensive. So if you're building a true NAS server, if you just happen to have a motherboard from an old machine and a bunch of drives, then that's all you need to get up and running. You don't need to pay for any additional software. If you're buying an enclosure, you're paying a lot of money for that enclosure because of the software that will be able to run on that. So the Synology Disk Station Manager, I think it's called DSM, that's essentially what you're paying a lot of money extra for when you buy the Synology drives and enclosures. Limited customization, so if you're buying something off the shelf, then it is what it is. You can't typically go in there and add additional stuff to it. So I've chosen a particular type of Synology drive, the 1522 Plus, and that means I can, the actual drive has 5 drive bays in it, but it has the potential to have 15 drive bays available, because you can plug into the back an extender unit with an additional 5 bays in it, and then another additional extender with another 5 bays in it, so you can have a total of 15 drive bays just with this one system. And the extended drive bays just don't have the intelligence on there. They just provide themselves as like a connection to a disk with power. So what you buy is kind of fixed in time. You typically can't upgrade that unless the device you're buying is designed to be upgraded. So that's why I've gone for the 1522 Plus. So they're the pros and cons of buying and building your solution. And it was interesting at the beginning of the stream, somebody was saying that they always think that it's better, or in their case, to use a build your own solution. I've had that issue where there's an incompatibility somewhere in the hardware stack. I don't think it's software. I think it's just something in that RAID card. I remember when I built that, I had to do some clever stuff with the kernel, or not so clever stuff, because it wouldn't recognize that card. And I think there's some kind of conflict, some kind of hardware interrupt or some issue there. So I thought we'd also just cover off cloud versus local storage. So I'm also looking to reduce down the amount of subscription fees I pay to have my data held in a cloud solution somewhere. And this is specifically with Adobe Creative Cloud. I'm paying an additional amount of money for their Lightroom cloud storage. So a lot of my photographs, my old photographs, are stored up there. There's about 1 terabyte worth of photos. I actually want to pull that back down and store that on my own NAS, so I don't have to keep paying that monthly fee on that. So cost-wise for cloud backups, you'll have these monthly fees, and that can grow with the data size that you use. If you have a local NAS backup, then you've got the upfront cost of buying the NAS enclosure and the drives, but no monthly fees. Your data is your own there. Speed-wise, cloud, unless you've got like ridiculously stupid fast broadband connection to the internet, it's going to be slow to upload and download data, particularly with large files. So the bandwidth will be a bottleneck there. With a local network area storage, it's as fast as your home network or office network. So if you're using Wi-Fi, that's actually pretty slow compared to if you have a wired connection. So when you're talking about drive connection speeds, I think 10 gigabit is now the preferred speed for networks. It's not going to be the bottleneck. If you use 1 gigabit connections, that's good, but you're still going to be capped out about 128 megs per second. I think that's right. Reliability wise, so cloud backups, they can suffer syncing issues. I've had this with my Macs, where I get multiple file folder names with the same name but with an extra number on the end, so it just doubles the amount of storage I'm using. Or you can get cloud outages. That's not unheard of, even on Microsoft 365. Now with local NAS backup, you do get drive failures. Drives definitely will fail over time. This mean time between failure does mean that your drive will die at some point. But if you have a RAID array and you plan for to upgrade your drives towards the end of that mean time between failure, then you'll have that covered off. So, and if you've got a backup as well, then you've also got yourself covered there too. Security wise, so cloud backups are more vulnerable to cyber attacks and ransomware if they're not particularly well protected. So you're really putting a lot of trust into how well they are securing, the cloud provider, your data. Local NAS backups are generally more secure because that data stays within your local network. Now you could, if you're foolish, open up your SMB, your send message block data to the world, in which case that data doesn't belong to you anymore. People can access that from anywhere. People can actually scan your network remotely to see if you have that kind of file transfer protocol, that SMB. That's kind of a file system protocol for networks. Accessibility wise, so cloud backups are designed to be accessible from anywhere. Great for home working, for remote working, for home working and sharing with family and friends. Local NAS, they can include an ability to share that data externally, but it can be a little bit more fussy to set that up. So you need to set up some kind of remote access to that. Synology's got a really nice thing called Synology Drive and a Synology Photos app, so you can share that with family and friends outside of your home network. You can also access your files if you wish outside of that network too. Maintenance wise, cloud backup, they do all the maintenance for you, all the backing up of the data, all the replacing of drives and air conditioning for data centers. They take care of all that kind of good stuff. If you have a local NAS, you need to pay your electricity bill. You're responsible for making sure that hardware is kept well, the firmware is updated regularly, backups are taken, all that kind of good stuff. So it's entirely up to you to do that maintenance. Cool. So I thought I would just cover off a little bit terminology. I know this is a little bit slide heavy this week, but I just wanted to sort of share this. So RAID, as we've said, is a redundant array of inexpensive or independent. Sometimes you'll see that written as disks. So that's a method of combining the physical drives into a single logical drive for redundancy and performance reasons. SHR, as I've talked about previously, is this Synology hybrid RAID, and it's a flexible RAID by Synology that allows mixing the different sizes of drives while still providing redundancy and efficiency of the storage that's used. Copy on write. We didn't really talk about this before. Copy on write is a really clever method of writing to disk. So back in the olden days, when you write, or if you're using something like a memory card and you're writing a file to that, if you decide that you want to make a change to that file, typically there is a file pointer in the file system, and it moves to wherever you're writing to. So if you want to add to the end of a file, it'll move to the end of the file and it'll begin writing to that. Now that can be bad for a number of reasons. If there's a power cut in the middle of writing over some data, what state is that file in when the system comes back up? It's in an unknown state. We don't know whether that file data was written or not written. Now you can get around that by something called journaling, which essentially has a log file separate to the file that you're writing to, and what it will say is it will write down Kevin is about to write some changes to this file. It then writes the changes to the file, and then it will say that change was successful. And if at any point during the operation of writing that data and writing that journal there was a power cut, the operating system can check the journal and see how far it got and essentially replay that journal, because the actual data that's going to be written is also written to that journal as well. That's not a particularly fast way of doing things, but it's a very structured way and guarantees that your data is going to be good. Copy and write does something really different, and this is more in the world of solid state drives and solid state memory. And it will copy the data only if the data is being changed. So you have an empty space to begin with, you start writing a file, that file exists over here. If you then want to update that file, it will actually update it over here instead, and then after it's finished doing that, it changes the pointer to the new file. And in that way you've got two copies of the data while the file is being written, and only at the very end does it move the pointer, and it actually leaves that on disk or in memory until that gets overwritten later on. They call this trim. If you ever use SSDs, that's part of the trim. It gets rid of memory that's being used that doesn't need to be there anymore. So copy and write is a really cool technique. It's a technique where data isn't overwritten directly, instead changes are written to a new location, preserving the original, and this is also useful for snapshots. So snapshots are a point-in-time copy of the file system, and it quickly captures the state of all the files and the folders in a specific moment without duplicating the data. So that pointer thing I was talking about before, there's a list of those pointers, and that is essentially the state of the file system. So that might be called a file allocation table. It might go by some other names now, but essentially it's like a list of pointers. You can take a snapshot of that, and as long as you don't change any of those locations where the data is being pointed to, then that snapshot means that we can have multiple snapshots of your data. And what will happen is when you take the snapshot, it will update that index and say this snapshot was taken at this time, and then if you want to change any of that data in the future, then it will know that that snapshot was taken, and therefore it needs to keep that data on disk and write it to a new area and point the new pointer to that. But you can actually roll back to that previous snapshot and still have access to all that data. So snapshots do take up space, but nowhere near as if you have an exact duplicate of that data. So it's only if the data changes does the snapshot kind of grow the amount of usage that it has. So as it says there, point in time copy of the file system quickly captures the state of files and folders at a specific moment in time without duplicating all the data. So really fast restores are capable with that. We've looked at checksums. They're this mathematical hash used to detect data corruption. It can automatically verify the integrity during the storage and transmission, and it helps spot bit rot or silent data corruption. We looked at backups and the 3-2-1 rule. So if you haven't got backups of your data or your daily drive computer, please think about that. You always find out that you need data backups after the disaster has happened. So please make sure that you use full the capabilities of your machine to make sure you've got backups of data. Now, worm is a really interesting principle. when we used to have DVD drives back in the day, they are essentially write once, read many. So you could burn a CD, but once you've burnt it, you can't then change that data. It's fixed. Now that's really cool if you want to make sure that that data never changes. So if you have really important, say, bank data, and you want to make sure that somebody can't come in there and change that data, then write once, read many is exactly what you're looking for. And a lot of backup systems and network area storage, network attached storage, will allow you to switch on worm for folders for a specific amount of time. And this is to prevent ransomware. So even if somebody had access to your data, they can't change that data. The system physical will not let you do that. So you might say that you want to have worm enabled for all your backups for 30 days. So you've got 30 days worth of protection. And even if somebody had access to that data, they can't change it. They can just read it. Deduplication. This is the idea of you only want to store a file once on your media, and therefore you're making the full use of that storage media, the capacity. And you can do that by deduplicating files. You can look for files that are exactly the same. And the quickest way to do this is using checksums. So that very checksum that you check to make sure the file has integrity, you can use that same checksum to see if files are likely to be the same or not. So that's how deduplication systems work. They just look and compare the checksums, and if they find that two files have got the exact same checksum, it's most likely that those files contain the exact same data. So if that's the case, you can actually get rid of one physical file and just have the file system point both instances of it to one physical data. And we typically do that in backup solutions so that we're not wasting space on our backup media. So deduplication is something you can enable on your network attached storage. Retention is how long you want to keep that data around for. So we typically talk about this if you have a company and you've got data that's commercial data or financial data, there might be a regulation that says you have to keep this data for 7 years, and that's the retention period. So we might want to set retention period for our backups to say 30 days. So after 30 days, a backup is then deleted and that space is reused for the next backup. So retention is something we can typically use to help make sure we can delete all versions of files, all snapshots, and we can do that automatically. It's a kind of rolling window. And finally, compression is how we can reduce file sizes to save disk space of that data stored by compressing that onto the network attached storage. And this is often invisible to the user. In fact, ZFS can compress those stripes of data. It can compress that at the block level, so it's making the most use of the space there without you even knowing about it. And it's lossless compression, so we're not actually losing any data. We can rebuild the data from the original compressed data. So like I said, often invisible, improves capacity without sacrificing access speed. In fact, compression is one of the techniques that was used when macOS came out as macOS 10 back in the day. It would use compressed memory to make the available RAM that's available seem more, because it could actually compress the data that's stored in there. And compressing data, there was some hardware that would actually be optimized for that. So it's faster. Doing input-output operations on a computer is typically slow. The CPU is sat there twiddling its thumbs waiting for that data to come in. So you can actually have it do the compression and uncompression while it's waiting, and it gets there just as quick, and you've also got more capacity available. So compressed memory, Windows does the same thing, and I think Linux now uses that too as well. So file system formats, this is a bit of a geeky thing to talk about, but I thought I'd just cover this off. So back in the day, Windows, or even before Windows, that used to use something called FAT, File Allocation Table, and it's a format of writing files to a disk. So your floppy disks even had the FAT system, and if you have a USB memory stick, they typically use exFAT. It's a very, very common format. SD cards typically use exFAT as well. It's a really open standard, and it's based on that original FAT file allocation table. I think, is it Dave Gardner? What's the guy's name who does the Dave's Garage? It's not Gardner, is it? I can't remember his name now. Anyway, he actually was involved in putting that format together, I believe, and I think he's done a couple of videos on that, which is well worth understanding. So file allocation table, I think typically on a disk you would have like 2 copies of that. You've got your primary copy and like a backup copy, and they would kind of rotate around so that you've always got a duplicate of that file allocation table. So if anything happened to that, you can use a secondary copy. So it's quite an efficient use, and the file allocation table just has a list of all the files, when they were last accessed, who accessed them, all that kind of information. So it takes up some of your storage just to do that kind of housekeeping. So FAT is actually limited to 4 gigabytes. That was just a limitation of the actual number of bytes that was used in the records of the file allocation table. So in a 16-bit operating system, which is what Windows was, then you can only access 4 gigabytes of memory. You'd have to use an enhanced version of Windows if you wanted to have access to Dayplumber. Thank you for that, Martin. That's the name of the guy who was involved in a lot of the low-level Windows code. So yes, 4 gigabytes is the actual maximum amount of size that you can access with the is it 16 or 32 bits. So that also limits the size of the volume to 2 terabytes. So 4 gigabytes is the maximum file size. If you break down how many blocks of data that uses, then you can only store 2 terabytes worth of 4 gig files using that same number of bits. And you can read and write them using Synology DSM. So that means we can use a FAT. We can plug in a FAT enabled drive, and our Synology NAS will be able to read that. exFAT, like I said, is the modern FAT version. Still used a lot on external drives, USB memory keys, SD cards, and so on, or SDXC cards, as it says there, and external SSDs. And that means you can use it from a Windows machine, a Mac machine, and it can read between them. I don't think exFAT has permissions though. So that's one of the limitations there. You can't say that Kevin has access to this and Alex doesn't have access to that with exFAT. It doesn't have any kind of layer of permissions on there. On Apple, when they very first came out, they used something called the hierarchical file system, and that then got upgraded later on to in later versions of macOS to be HFS Plus, and that's Apple's very old macOS file system. Still used on Macs. And it can still read and write to that format. Synology actually lets you read from that type of formatted drive, but Apple has since moved to this Apple APFS filing system, which is their latest version. APFS is the current version that's used on their internal SSDs. It can do a lot of the clever stuff that we will be looking at with the Synology one, which uses BTRFS underneath, if you're interested. So APFS is designed for encryption, snapshots, fast directory sizing, all that kind of stuff, but Synology doesn't support that at all. So if we put in a drive that's been formatted with Apple's APFS, it'll not be able to read it. For a long time, Windows uses NTFS. It might be that you're using a version of Windows that still uses that underneath. And NTFS is kind of a souped up version of the file allocation table. So it can do permissions, it can do journaling, it can do very large file sizes. It can do long file names, which back in the day was like a big deal. You could only have file names that were 8 characters long with a 3-character extension on the FAT file systems. NTFS, you could have 256 characters for each file name. Since then, you can do things like compression. You can enable that or disable that for on either a file level or a drive level. And NTFS also lets you do things like volumes, which is a way of separating out on a single disk. You can have multiple volumes, and it's just a way of kind of splitting out the capacity that's actually used there. Synology will let you read and write to external drives. Just say write is a bit slower on that for NTFS. Then BetterFS, or ButterFS as some people might call it, BTRFS, is the modern copy and write Linux file system with snapshot support. The self-healing comes by the fact it can use those checksums to compare the data. If there's a problem with that, it can look to a redundant copy, or if you've got a RAID, and it can rebuild that from the parity information. Also has support for quotas and efficient snapshots, and that's fully supported by Synology. In fact, that's what it uses behind the scenes. One of my favourites is ZFS. This is the enterprise grade file system with very strong data integrity. They call this RAID Z on systems that support ZFS. and it combines the file system with the volume manager. So volume manager, we'll have a look at this on the next slide or two. Volumes are a kind of an abstraction above a storage pool. So a storage pool can take the capacity of all your different drives and present as one logical pool of capacity, and then you can then break that down into individual volumes. And I always think of this as like books on a bookshelf. So the storage pool is the shelf, the volume is the actual book you're taking off, and then the pages in it and the individual kind of files and folders that are in there. So ZFS is not supported but on Synology drives, but there are some third-party tools if you want to be able to read that data in there. And then finally we've got the XT3 and XT4, which is the standard Linux file systems. XT4 is kind of the default for most Linux distributions behind the scenes. It supports journaling, which is that writing of stuff before you commit it to disk, as well as very large volumes. So fully supported by Synology DSM as well. So how I'm going to configure mine. So this is what I was talking about between the physical drives themselves, the storage pool, which can use all or a number of the drives, the volumes that can then exist within that storage pool, you're not limited to just one, and then the file system format that volume is formatted in. It doesn't have to be BTRFS, you could format this as any supported format. You could have like a Linux format if you wanted to do that, typically. So this is kind of what I'm going with my Synology drive when it finally arrives. And this is the process I'm going to go through because I've got all this data in all these different places. So I first need to declutter that. I need to consolidate all my messy storage into a single NAS storage device. So I'm going to copy everything across essentially. That will then help centralize all the data that I'm using into a large storage pool. And it's mostly the photographs, the video, and there's a bit of code in there, but that doesn't take up very much space, to be fair. And that means I've then got, having centralized thing, I can then make the backup of that data much simpler. Whereas at the moment, when it's spread across all these different on and offline drives, if I want to take a backup of this, I've got to physically plug them in, take that copy, and remember which drive that came from if I need to restore it. I'm then going to optimize my use of disk space and storage across all the different subscriptions that I've got, so I can cancel the Lightroom cloud storage, reduce down my the amount of data that I'm storing to my Apple iCloud, because I don't need to use as much data on my Mac on that drive as well, because I've got it locally. Safeguarding, I'm going to have to begin with a lacy rugged drive plugged in the back of the NAS, and it'll take a backup of that. And that means once a week I can just unplug that, take that to the main house, which is like a physically separate building, and bring back a second drive and plug that in. So I can just rotate those round and always have like an off-site backup. Eventually I'll have two NASes, one in the house, one in the summer house, and that means we can have that happen automatically. And that means it's kind of ransomware proof. If anybody happens to get access to a physical my NAS that's actually online, I've got the offline copy which is stored off-site as well. So I've still got access to my data. They can't ransomware me and encrypt it and then charge me for that. And then I'm going to be using that. So that's one of the main things. So I've not been using my TrueNAS server since I've had those issues where I'm doing those large file transfers and it breaks halfway through and I have to redo it. And I don't know whether it's taken the file or not taken the file. So it's really difficult to keep up with that. And capacity-wise, so I've gone with 3 16 terabyte drives. These are the drives I could get hold of. I actually tried to buy 18 terabyte drives. I tried to get the largest capacity that's available. And what I could afford to spend at this. These are about £200-300 each, so they're not cheap. I've got 3 of them. The drive actually, the enclosure has 5 bays, so I'll have 2 spare capacity bays for future drives going in there. I'll be using that Synology Hybrid RAID, which is the recommended configuration. So their index of your files is 27.9 gig in size, which seems huge, but that's what it takes for 29.1 terabytes worth of available capacity from those 3 drives. And that means that 1 drive's worth of data just underneath 1 drive is the redundancy that's needed. So there's actually a RAID calculator on the Synology website. We'll have a look at that in a second actually. I'll just add that to my demo notes because I think that'd be quite cool to look at that. So that's the RAID calc. So yes, I've got plenty of room there for future capacity. So this is one of the recommendations when I was doing my research. There's quite a few people who said don't buy and fill all the drive enclosures with like size drives, because you'll fill that and then you'll not be able to easily upgrade that later on. So fill a few drives with as much capacity as you can afford, and then leave some future capacity, and it means your drive enclosure can kind of grow with you as you fill it up. Cool, let's have a bit of a demo and have a look at my TrueNAS solution as it kind of currently stands. So I'm just going to log into it and just get this up and running, and I'll show you it. So I'm just going to log in. I'll just put the screen on once I've actually logged in. So if I go over here, I hit return. So this is, it's got a fixed IP on my network, so it always sits at 1.203. This is because I always want to be able to connect to this, and just remember, it doesn't find it on other machines. It doesn't necessarily pop up as a drive that's available. Sometimes I have to manually type this in for it to find it. I think that's to do with the Bonjour networking that Apple invented. Doesn't quite work perfectly on my network for whatever reason. So you can see on here I'm on TrueNAS 13, which is I think the latest version, and it's been up one day because I rebooted it yesterday just to check everything was good. There's no updates. I actually updated that yesterday. Now you can actually see the CPU that I'm using this. So this is a AMD FX 4300 quad-core processor. You Google that, that's about 12 years old. So that's like a real old processor. But you don't need a fast processor if you're using file storage typically. It just needs to take data requests in and process them out. So you can see there, it's not really doing very much. And you can see there the highest usage, how many threads I've got, and the temperatures and the thread count there. Memory wise, so it looks like I've only got like 12 gigs of RAM possibly in here, so it's not got a lot of RAM by today's standards, but most of it's free. So you can see there, we're not doing very much with the RAM, so it's actually quite efficient. And the ZFS cache, which is used for doing the deduplication as well as just the general file processing, compressing and unpressing data, that is very low as well, because I'm not really using the drive at the moment. And we can see over here, storage wise, I've got 4 disks for data. The storage pool is online, everything's good, there's no errors, and it's got a warning 92% full, because it is really, really full. I've got 200 gig currently available there. We'll have a look at the drive configuration in a second. You can see there I'm on a 1 gigabit network connection, and I've got 2 interfaces. The second one isn't actually plugged in. I could probably double that by doing some port, what's it called, aggregation, where you sort of add the storage, you add the bandwidth capability of both network cards together. So let's now have a look. I think account wise it's just me on there. I don't think I've got many. Yep, just me and root, and I've not really gone and done anything clever group wise. I could set this up as like a family thing if I wanted to. So you've got these system options down here, and it's typically like how it reports errors, who does it email if there's a problem with the drive, any cloud credentials, SSH connections, updates and things like that, as well as network time servers. Tasks is if you want to have a cron job. Cron is a Unix task scheduler. So if you want to be able to schedule this to say restart every day, you can have that happening there. If you want to schedule smart tests, smart is a way of testing drives to see if they are healthy or not. It's like done at a hardware level, and you get like pass, fail, or information if that happens. You can schedule periodic snapshots. We talked about snapshots before, which is kind of a point in time. And this is a ZFS configuration I've got going on here, so that supports snapshots. So we could do a weekly snapshot if we wanted to, and that's a way of kind of not quite backing up data, but saying this is what the data was like at this point in time. So if you want to be able to roll back to that point because you made a mess of your data, you can get back without having to go to a backup solution for that. So it's kind of the first level of resilience there. There's replication tasks. If you've got another TrueNAS server, you can replicate data between the two of them. That's pretty cool. That's quite straightforward to do there. And resilvering is when we do that data scrub. We can actually kick off a scrub in a second. I'll show you what that looks like. It checks all the checksums on the file system, and resilvering is if one of the drives fails and you swap that out, you can actually prioritize when and how that happens. So scrub task is that scrubbing of the data, checking all the checksums, self-healing if there's any issues, and then I think there's something called cloud sync tasks. I'm not typically use that. You can configure your network in here through the network interfaces. Storage, let's have a look at the pools I've got. I think I've got 2 pools on here. So there's a IO cage, Mastodon. I think I was going to set up a Mastodon server. I never actually got round to doing that. And then there's VMs, which is just for virtual machines. I was having a little separate storage area for that. Snapshots, I think there's just that one snapshot which it did automatically itself when it upgraded to 13.2. VMware snapshots, I don't use VMware on this, so there's no snapshots in there. And then the physical disks, I've got 5 disks, all 1 terabyte. I suspect that boot volume isn't using anywhere near that 1 terabyte of space there, so it's probably quite wasted. And you can see that I've got 4 drives in total that are for use in the storage pool called storage. You can actually import disks as well, just using this disk import tool. You say what kind of format it's using, and it can then import that data onto the NAS. Directory services is typically used if you want to make like an Active Directory. That's what Windows uses to store all the user accounts. You can do that. LDAP, Lightweight Directory Access Protocol. Windows Active Directory uses LDAP in the background, but you can set up LDAP if you want to have access to that user directory as well. NIS is another kind of directory protocol, and then you've got all the Kerberos, which is kind of certificates for making sure everything's nice and secure. Sharing, so you can share using lots of different protocols. So Apple file protocol, that isn't used anymore really by Apple devices. They've swapped out that in favor of SMB, send message block. That's what Windows uses to share files and to be able to open up shares on a network device. WebDAV is a protocol for sharing files over the internet. And then you've got the Unix network file system, which is how Unix systems can share files between each other, how they mount file systems. iSCSI is really cool. This is a way of, at a very low level, creating a share between this device and other devices. So if you wanted to create a virtual machine, and that virtual machine can connect to the iSCSI interface as if SCSI was like a small computer systems interface. It was a way of connecting, like we have SATA and IDE for connecting physical drives. SCSI was another method. Apple typically used that one back in the day. So iSCSI is like an internet version of SCSI, where you can actually send those file blocks or data blocks over a network. And it just means you've got really low level access to that, and to be able to share that across to other machines. Services is we can enable different file sharing services that we've just looked at there. So I've got iSCSI enabled, NFS. I've not got the Apple one enabled, but I've got SMB, which is the Windows, and modern day Macs use that. You can add extra plugins. I've not got any of these installed, but things like Plex, media servers, SyncThing. There's a whole bunch of whole ecosystem of plugins available for TrueNAS. Jails is a way of running. It's a bit like Docker containers. In fact, you can see there's a Docker dev in there. That's just a FreeBSD way of doing kind of Docker. Excuse me. Reporting is the kind of stats from your system. As you can see, like the temperature of the system and how loaded it is. Mine's not even using 1% of its capability, so it's really underutilized. Virtual machines, you can actually create virtual machines in TrueNAS and have quite lightweight machines there. So you can see I've got a Docker VM, I've got I think another Unix service there, and then a Windows 10. And you can simply just fire this up and it will start up a virtual machine that you can then connect to, which is kind of hosted on this machine, but it doesn't have a great deal of RAM, so it's not particularly great. And also the processor's 12 years old. How good is that going to be? And then you've got things like shell access. So let's actually go into here and have a look, have a poke around. So this is using ZFS. So if I do zpool status, we can see there's a pool that's called storage. You can see the name up there. It's online, and the last scrub was done on Sunday, March the 2nd, so about a month ago, and everything was good. You can see that this is a RAID Z configuration, and there's 4 drives in that Z pool. So if I wanted to do a scrub, I think I do the word scrub, and then I think you have to type in the pool name. So storage, it's called, sorry, not storage pool. It'll come back to the command line, and if I now do Z pool status, let's just do that again, you'll see there that a scrub is in progress, and it's scanned 600 gig so far at 99 gigs per second. If we now look and do that again, you can see it's done a terabyte has been scanned so far, so it's really quick because it's just reading the checksums and comparing that to some of the data, so it's actually pretty quick. And we can keep looking at that and see what the percentage is that it's completed so far. If there's any issues, it'll flag that up and send out an email if there's an issue. So that's like the low-level drive configuration. Now, if we want to actually look at the storage volumes that are on here, if I do ZFS list, we can see we've got a whole bunch of different volumes on here. So there's the boot pool root. So we can create on here, let's go for the storage one. Let's create a new ZFS create storage pool, and we'll call this one a live stream demo. Oops, I typed the word create wrong there. Let me just type that correctly. And this will create a new volume. So I keep tabbing storage pool, it's just storage. It's because that's what it used to be called back in the day. There we go. So that'll create a new, it looks like a folder, but it's actually an entire volume. So if I do ZFS list again, we will now see that we have live stream demo there. So if I go into storage, I think on this one it's mount storage, I can then go into live stream demo, and there's nothing currently in there, so I could just let's just create a readme file. Let's edit that. I think I've got Nano installed on here. Hello world. Let's just save that out. So if I now look in that readme file, we can see it says hello world. Right, we can now create a snapshot of that entire storage volume. So let's do ZFS, I think it's snapshot. This has been a while since I've done this. I'm just going to type snapshot and see what snapshot and see what it tells me I need to do. So I need to say snapshot and then the volume name. So it was storage live stream demo, and then an @ and then we need to do the name of the snapshot. So I'm just going to call this Sunday March 30. So that will then take a record of the current state of that volume, and it will store that as metadata. So if I do ZFS list, sometimes you can see these in here. I think sometimes you have to do -T. Was it all? And then snapshot to see all the different snapshots that are on here. So there's actually quite a few snapshots on here. So if I scroll down, we should see one that says live stream. There we go. Storage live stream at Sunday, March 30. So let's modify that file that we've just created. Let's go into that README file, and let's change this file. You have been hacked, something like that. Let's just save that out. Okay. And we can now restore that snapshot if we wanted to, or we can take another snapshot. We can take as many snapshots as we like. So let's go actually and do a snapshot, but let's call this one hacker, something like that. Now if I go back and I do that ZFS list -T for type and then snapshot, we can see we've got two snapshots. One is 81K long, and we've got another one which is 0 bytes. So we've not made any changes to the volume, so therefore there's no data actually being used by that. And over time, if we create lots of snapshots, as the data changes from those snapshots, it changes because we've changed the data in it. You'll see that that usage also grow, and it'll keep growing until we remove those snapshots. So we can actually remove that March one. So if we go to ZFS, I think we have to type destroy, and then storage pool, and then at, sorry, slash live stream demo, and then at, let's do Sunday dash March dash 30. So it's not happy with that. What if I type wrong? Storage pool. I keep typing storage pool. Let's just do storage. There we go. That will now remove that. If we go back to our list, we can see we've just got the hacker one, and that 81 kilobytes of data that we're using, which was you've been hacked, is literally the length of that text string. We've now recovered that because we're no longer keeping a record of how that file was before we made that change. So snapshots are a really cool way of kind of marking a point in time. And ZFS, you can actually send snapshots to another ZFS storage array. So it's a really cool way of kind of sending off all the changes that have happened since a point in time. So if you were to do this sort of daily or weekly, you could send that to another offsite TrueNAS box, and it'll just send the things that have changed rather than sending everything. So it's really efficient, and that's what snapshots are particularly useful for. So that's that. Let me see if there's anything else I wanted to cover off. So yeah, currently I think I've got not too many. If I go back to my machine, I'm just going to show you what this looks like. So if I go over here, I can see on my thing on the left hand side here, the TrueNAS box. I can see I've got two shares currently, Kev and storage. If I go into storage, you can see we've got live stream demo, which we literally just created, and within that there is that readme file which now says you've been hacked, and we've got all the other things like the virtual machines, that Mastodon instance that I was going to create. Can't remember what IO cage is, and then we've got Kev, which is like the main place where I'm storing files. So I've got a lot of the show archive is like the majority. You can see there 2.46 terabytes of stuff. Woodbot, I think, is a video I made about the laser cut robot that I created, and this is typically a file structure for a video project that I've got. So I've got content which has got all the video files in it, Woodbot 1 and 2, any still screenshots, any graphics used, any screen recordings, any film or audio. If I type in a script, I typically store the script there as well, and then the actual project file. So this is the Final Cut Pro library that I create to store the contents of that. So that cache file could probably be deleted without actually corrupting any of the contents of that Woodbot. It just creates a cache when you create a video of all the video assets that's rendered for that. And then typically I will output that as a final, so the final video Woodbot, which is the one that will have been broadcast to YouTube. If I click on that, you can see there's the video I created, and that's 16 gig in size, so it's quite big. But that's the final asset that I created. I could get rid of that and just have the source files and the Final Cut file, but I also like to keep these as well. So that's typically the shape of a show when I do a pre-recorded show, and I like to store those in my show archive. So really that should be inside there. So you can see that I've got a lot of content there. There's lots of GoPro footage. They're like pretty big files as well, typically. So you can see that's like 2 gigs of, sorry, where's that one gone? Oh, there's nothing in that one, that I've clearly moved it. So yeah, but I've got quite a lot of GoPro footage. Diving in Sorrento, there's like 15 gigs of data there. Final Cut events, there's 28 gigs of video stuff in there. That's probably not even up to date now. And then I've got two libraries, YouTube Video Archive and Jalapeno 9000, which I can't remember what that was to do with now. That was some show about growing chilies, I suspect. So this is really what I use my storage pool for. It's mostly for storing the shows that I've created for YouTube, and I'm running out of space on there. So that 32 terabytes of space that I've got sat on my desk waiting for the enclosure to arrive from Amazon, that's what's going to sit here. I'm just going to check on and see where that order's up to actually, because it says it's going to get here by 10 10 p.m, but it's not even out for delivery yet, so I suspect what's going to happen, it's going to get to 10 o'clock and they'll say, sorry, that's not been delivered today, it'll be delivered tomorrow. So that is what it is. Cool. Oh, the other thing I was going to show you was that RAID calculator. Let me just show you that quickly, because that's also pretty cool. Let me just rewind that. Okay, and let me go to the RAID calculator. So this is on Synology's website. So this is the enclosure that I've got. And I think if we type in the search box over there, RAID calc, it'll take us to the RAID calculator tool that they have, which is pretty cool. So this kind of shows you for a given number of drives. So I've got 3 16 terabyte drives. So if I put them down here and I change this over to the Synology hybrid RAID, you can see there, this is that figure that we looked at on that slide before. So 27.9 gigabytes for reserved for the system use. There's the available capacity that we can use to store our files, and then that protection, that kind of redundancy, that's because one drive's worth of storage, almost one drive, has to be taken away for that. We can also look at this if we add in, let's go for RAID 0. So if we wanted to just use all the capacity of the drives, you can see there we could have 43 terabytes, but we would have no protection if any of those drives failed. We go for a RAID 1, so we've got some mirroring going on there. Then we've got 14 terabytes of usable space, but 29 terabytes worth of protection. So essentially we've got one drive, and one drive is mirroring it, and then there's just a drive kind of left spare there. We go for RAID 5. That'll be very similar to what we've got up here, because this hybrid RAID is essentially the same thing, but we can do some clever things on this, such as let's add in 2 1 terabyte drives. Say I wanted to reuse, let's do 4. I wanted to reuse those 1 terabyte SSDs in here as well. If I had 7 bays available, then you can see there with RAID 5 we can only use multiples of the smallest drive size. So if the smallest drive size is 1 terabyte, then we can only actually have 5.4 terabytes worth of capacity available to us, whereas with the Synology hybrid RAID we can actually have 32.7 terabytes. So it can actually do some clever stuff in the background and split those sets of disks up into kind of RAID pairs and RAID kind of RAID sets, and then provide all that storage available to us. So this is why this Synology RAID hybrid RAID is actually quite clever in how it works compared to a traditional RAID. And if we went for like RAID 6, I don't think, well, there we go, it's even less space there. So that's the RAID calculator. It's quite a cool thing to play with. You can also do it with SATA drives as well. You can just play around with this and see what you would end up with. So I've got a couple of 2 terabyte drives. We could see what that looks like on there as well. So yeah, pretty cool. There's a whole bunch of different types of Synology drive. I had to do quite a bit of research on these. So the way that these work is, if we start out with this one here, for example, so DS just means disk station. That's the name of the product line. 4 is the number of drive bays available. So these have like 4 drive bays this size. And then the last 2 digits are the year that this was released in. So 23 is like 2023. Ones where they have like 9 or 15, that means that you have a number of drives to begin with, but you can add a cable and another extender enclosure to that to get a full set. So this one here has 4, but you can add an extra extender that's got 5 drive bays in, making 9 possible drive bays, and it was released in 2023, and the plus means that it's got that extra capability that you can extend it later. They do 1 and 2 bay enclosures as well, and it's basically just recommending this based on how many things I'm putting in here, just out of interest. So the whole product lineup is actually vast. So if we go for it, actually, like, are you a home user or a commercial user? So if we go for advanced data management, I think you can see the kind of lineup that they have there. So you can go for like 8 bay enclosures. 18 means you could have 18 potential with the extender products in there as well. That one there has 24 possible drive bays, and then we can have right down to like a single drive bay. So you can actually say how many drive bays that you want to have available. So let's go down to 2 bays and see what that looks like. You can unselect the filter on there as well, so you can go down to like a 1 bay drive enclosure. That's what it looks like. I think that's the cheapest one that they do, and I think it's under $100 to buy that. But you do have access to the software, so you can share this content via the Synology Drive app as well. So they've got this value series. So yeah, it's worth having a play around with if you wanted to look at this. And there's quite a few videos on how to choose your Synology RAID as well. So I'll just share that with you. Cool. So I just want to do a quick plug of my own products here. So we have the Robot Maker's Almanac. If you make robots, this is an essential piece of information that you want to have to hand. So it's got all the dimensions of all the typical things you use in robots, so servos, motors and so on, and all the microcontrollers like Raspberry Pis, Arduinos. All the physical dimensions are in here, as well as what the pinouts are, so what all the actual GPIO pins are for each of the different microcontrollers. And then there's also other information in here about things like motor drivers and things like how the what the different colours mean on resistors and some of the electrical diagrams. So this is available from kezrobots.com, and we also have Maker Notes, which are blank notebooks which are optimised for doing things like circuit diagrams. There's some very small dots on here, you probably can't see it because of the bright studio lights, but it's perfect for making sort of circuit diagrams, but the dots are so subtle that they actually don't get in the way, so if you want to do like a freehand sketch, you can do that as well. So these come in packs of 3 in some nice vibrant colours, all handmade by me, as well as the Robot Maker's Almanac. And then we have a range of PCBs. So this is the gamepad, which I designed, the gamepad 2. So it has a Raspberry Pi Pico W on the back. You simply just drop that in, drop in a OLED screen and 11 of these little momentary push switches, and you can get yourself a remote control. It can use Bluetooth or even Wi-Fi to connect to your robots using the chip on the Raspberry Pi Pico. All works with MicroPython, so very nice and easy to do, and they're only £6 to buy, so they're very, very cheap, very affordable. So head over to kezrobots.com and you'll find information about how to buy those and get yourself some fun. So if you haven't joined our Discord community, we are all over Discord. There's a really great community of people on Kev's Robots Discord community. You can share pictures of projects you're currently working on, ask for help, and all kinds of things like that. So definitely, if you haven't joined that, it's completely free. And yeah, just head over to kezrobots.com/discord. And if you want to follow me on social media, I'm on all the social media platforms. So I'm on Threads at Kevin McAleer at threads.net. I'm on TikTok at Kevin McAleer6. I'm on Instagram at Kevin McAleer. I'm on X at KevsMac. I'm on Mastodon at kevsmac at mastodon.social, and I'm also on Blue Sky at kevsmac.bsky.social as well. And I'll post all kind of behind the scenes pictures of things I'm working on that might be of interest to you as well. And if you want to join me and support the work that I do, then you can head over to kezrobots.com/coffee and get your name in the end credits. We'll be saying thanks to some people who've done that already very shortly. If you want to buy a coffee, you can do that as a single one-off coffee purchase, or you can contribute a coffee per month if you want to do that too, through the Buy Me a Coffee link, which is through kezrobots.com/coffee. So let's give a shout out to the people who have supported the channel so far. So on the left hand side over here, I've not had any coffees in the past month. Maybe it's just that time of year people don't buy coffees, but yeah. Little sad face there. And then members of the Buy Me a Coffee, we've got Silicon Fiber, Marie TKD, we have Andrew, Shemi, Jeff, Dean Corty, Marlene and Tom. And then over on the YouTube membership side, we've got Bert, we've got Dale from Hybrid Robotics, Marie, Michael, Steve, Ford, Bello, Oxrad39, Littleback, Paul, Johnny, Stephen, John Paul, Cassie, Tinkering Rocks, Johnny, and we have of course Tom as well. So thank you so much for supporting the work I do. It means the world to me that you do that, and it means I can buy the things I need to develop things like these gamepads. This was like iteration 3. The very first version didn't have a version number on it, so developing things like that actually has a cost to it, so it really helps when you support the channel. So the little spinny logo means it's the point in the video where I'll say over here YouTube will be recommending a video from the over 400 videos on the channel so far that it thinks will be perfect for you. So definitely check that out and let me know what you think in the comments below, and let me know the answer to the question that I posed before, which is what kind of NAS device do you have? If you have one, what brand, and what size of storage do you have? Very interested to know that. And I'll say thank you so much for watching, and I shall see you next time. Bye for now.